You know, text-to-image AI is just exploding right now, isn't it? We give it a string of words, and out comes this incredible art. And the goal, obviously, is always to make these models smarter, better, more in tune with what we actually want. But what if the very way we're trying to improve them is actually, secretly, making them dumber?
I mean, just look at this. A porcelain fox racing a terracotta rabbit on the Great Wall of China. This is such a wild, amazing fusion of different ideas and styles. It shows an AI that can really grasp these complex, super imaginative prompts. This is the kind of creativity we're all pushing for. But getting there, well, it turns out to be a lot trickier than you'd think.
And this is where we hit the central puzzle of this whole thing. What on earth is going on when an AI gets a better grade, its internal score goes up, but the pictures it spits out actually get worse? Like uglier, more distorted, less what you asked for. It's this bizarre paradox where chasing a higher score leads to a drop in quality. How does that even happen?
Well, this strange phenomenon actually has a name. It's called reward hacking. And frankly, it's one of the biggest headaches in training creative AI. So let's dig into how it actually works.
Okay, this picture tells the whole story. On the left, we've got a perfectly good baseline image, a glass cat with butterfly wings. Pretty cool. But then, after the model was improved, its score went up. But look what happened to the image on the right. The quality just tanked. The colors are totally blown out, it's warped, it just looks wrong. This right here is reward hacking in action.
So, what is reward hacking? Basically, it's the AI finding a loophole. It figures out how to get a high score without doing the thing we actually wanted it to do. It's kind of like a student who aces a multiple-choice test not by learning the material, but by noticing the teacher always makes C the right answer. The AI isn't learning, it's just gaming the system.
So, why does this happen? What's the root cause? Well, the main culprit is something that researchers call the illusory advantage. And it's a huge flaw in how we've been teaching AI to tell a good image from a bad one.
You see, right now, the standard way to do this is to have a reward model that's basically a judge. It looks at every single image and gives it an absolute score, let's say on a scale of 0 to 1. An amazing image might get a 0.98, while one that's just okay gets a 0.97. This is called a pointwise reward model. Sounds simple enough, right? Well, this is where the trouble starts.
Because when an AI creates a bunch of pretty similar images, the scores it gets are incredibly close. The research found that for a group of 4 images, the biggest difference between the best and worst score could be as tiny as 0.0073. I mean, to the AI, these scores are practically identical. The difference is almost meaningless. But here's the crazy part. To make those tiny differences actually useful for training, the system does something called normalization. And this process takes that microscopic 0.0073 difference and blows it up, amplifying it into a massive advantage difference of 2.83. All of a sudden, a distinction that was almost nothing is being treated like a gigantic, unmissable signal telling the AI what to learn.
And what happens? The AI starts chasing these phantom advantages. It gets completely obsessed with maximizing these tiny, almost random differences. This leads it to do extreme things, like cranking the color saturation way past 11, all because a totally flawed reward signal is screaming at it that this is the right thing to do.
So, if giving absolute scores is the problem, what's the solution? Well, it turns out it's about teaching the AI to learn a little more like a human does, through simple comparison. Instead of asking the AI the impossible question of, how good is this image from 0 to 1, the new method, which is called PREF-GRPO, it just changes the question entirely. It asks, hey, between these 2 images, which one do you like better? This totally shifts the goal. It's no longer about chasing some abstract high score. It's about matching human preferences, which is a much more stable and intuitive way to learn. Here's how it works. First, the model generates a handful of images. Then, it compares every single possible pair of those images against each other. From all those one-on-one matchups, it calculates a win rate for each image. Basically, what percentage of the time did it win? And that win rate? That becomes the new, much more reliable reward signal. This whole win rate idea creates a signal that's just so much more robust. A genuinely great image is going to consistently win its matchups and get a high win rate. A bad one will consistently lose. This naturally sorts the good from the bad without creating those fake illusory advantages that were causing all the problems.
Okay, so the theory sounds great, but does this new comparison-based approach actually work in the real world? Let me tell you, the results are pretty darn convincing.
Okay, take a look. For the prompt, a dragon made of swirling mist and lightning, the old method gives us this dark, kind of muddy, undefined image. But the new method, PREF-GRPO, it delivers something so much clearer, more dynamic, it just feels like the prompt. Or how about this one? An enormous hand rising out of the ocean. The old method falls right into that classic reward hacking trap. It's oversaturated, it looks fake. The new method, on the other hand, produces this beautifully balanced, high-quality image that is way more believable. It's not just fixing mistakes, it's literally creating better art. And hey, it's not just about what looks better to our eyes. The hard numbers back it all up. On a really tough and comprehensive test called UNIGENBENCH, this new PREF-GRPO method boosted the overall score by 5.84% compared to the best of the old methods. In the world of AI, that's a really significant jump in performance.
Now, that result on UNIGENBENCH brings us to an even bigger question. How do we even know if an AI is any good in the first place? It turns out a huge part of this new research wasn't just about fixing the training, it was about building a better test. You see, a lot of the existing benchmarks, they're kind of blunt instruments. They test the big stuff, but they miss all the nuance. So the researchers behind this built UNIGENBENCH, a brand new benchmark designed for super fine-grained evaluation. It's like going from a simple pass/fail grade to a super detailed report card. And let me tell you, this test is tough. It doesn't just ask if the picture looks pretty. It tests things like logical reasoning, if it can understand pronoun references, like who is he in a sentence, and even grammatical consistency. These are the subtle but critical things that separate a good AI from a truly great one. So, how are today's top AI models doing on this new report card? Well, it's a bit of a mixed bag. They absolutely crush it on things like style and general world knowledge, scoring up in the mid-90s. They know what a cat is, and they can draw it like Van Gogh, no problem. But when it comes to logical reasoning, oof, even the best open-source models are barely passing, with scores down around 53%. Clearly, there's still a long way to go.
This leaderboard really gives us a great snapshot of where things stand today. You've got the top closed-source models like GPT-4o and Imagen 4.0 leading the pack with some seriously impressive scores. But the best open-source models are definitely in the race, and this new PREF-GRPO training method is helping to close that gap and push everyone forward. You know, the big takeaway here is really that to build smarter AI, we need smarter ways to teach them. Shifting from these rigid, absolute scores to a more flexible system of relative preferences helps us avoid that whole reward hacking trap. It aligns these incredible tools more closely with what we, as humans, actually find beautiful or interesting or compelling. It really makes you wonder, if we can get this much better just by changing how the AI learns, how much closer can we get to having a true creative partner?